Hello, everyone, and welcome to another edition of codeLive. My name is Charles Watkins, and I'm a lead developer advocate here at Salesforce and your host. So for this week's codeLive, we have a very exciting thing to show you. We're going to be exploring Salesforce's new Models API, which is currently in beta. It's a set of tools that allow you to bring powerful new generative AI capabilities to your Salesforce applications and beyond. Now, before we get started, as always, I am going to show you our forward-looking statement. So this is just a reminder that Salesforce is a publicly traded company, and as such, you should always make your purchasing decisions based on features that are currently generally available. Now, for this particular session, I'm going to be going through some slides. We're going to explore the new Models API in Postman and see the different tools that we have available and how we might be able to use them. And then I'm going to show you a demo that I built a few days ago that I've been using to use generative AI in my daily workflows powered by the Models API. All right, so if that sounds good, let's get started. So let's first talk about the challenge of integrating large language models into applications that are actually business ready. It's really easy to use consumer grade applications, but when it comes to business, it's a little bit different. So one of the first challenges to using large language models in business is that there's generally going to be one API per service. So if you want to have an application that can take advantage of all the different innovations that are being made by all of the different companies that are building generative AI models and generative AI tools, you'll have to integrate one API per service. The next thing is that in the context of Salesforce, most of these models won't have native support in Salesforce or Apex. They don't have a Apex SDK or something like that to make the process of integrating with those providers easy. And then the third reason is just trust and safety challenges. So if you work for a company, you might have been told by your IT team or your leadership that you shouldn't use consumer grade applications to try and solve problems, right? You shouldn't take a document that you're working on for your company and share it with whatever consumer grade chatbot you like to try and understand it or summarize it or parse it or anything like that. And that's unfortunate because these applications are actually really, really useful in day-to-day work. They can make a really big difference. Now, to date, Salesforce does have some tools that helps you. There's Einstein Copilot and there's Prompt Builder. But those two tools have very specific uses. Copilot is an AI assistant that helps you with essentially doing things in the context of your Salesforce CRM. So if you want help figuring out what high priority cases you have, Einstein Copilot is great. If you want to write an email, Einstein Copilot is great. If you want to inject a one-off prompt with a prompt template, Prompt Builder is great. But if you want to build something more complex, like a chatbot, up until today, up until recently, you could not do that. So that's where the Models API comes into play. So the Models API is a single interface that you can use via Apex or REST endpoints to integrate with a variety of different API models and API providers. You can use it to do one-off prompts. You can use it to build chatbots, which I'm going to show you a little bit later today. You can use it to create embeddings, which are kind of numerical representations of what words mean so that you can build your own kind of semantic search in your application or do retrieval augmented generation. We'll talk a little bit more about that later. And then you can also use a feedback format, a feedback framework that actually comes as part of this API so that you have a good idea of which generations are good and where you could improve. And then, of course, you can integrate over REST or Apex, which is great. So there's a native API inside of Salesforce. So it's really easy to actually integrate with these different providers. And then finally, and this is the really big one, when you use the Models API, when you use generative AI in general with Salesforce, you are taking advantage of something called the Einstein Trust Layer. And this is a secure software architecture instead of agreements that Salesforce has with its AI partners to ensure that the prompts that you send and the responses that you get are never stored or used for any future training sets. And that's pretty much it. So let's talk about very quickly that Einstein Trust Layer because it's really important. This is what potentially allows you to use this for your business. So the Einstein Trust Layer is essentially something that sits in the background of Salesforce when you are using generative AI, and it has a variety of different steps to ensure that when you're sending a prompt, the data is masked. If you are using something like Prompt Builder or Copilot, it can pull in data from Salesforce. It wraps your prompts in prompt defense. And very importantly, there's this zero retention secure gateway that sits between your prompts and the LLM providers to ensure that, again, nothing is retained, not your prompts, not your responses, nothing. And in addition to that, there's toxicity detection of the responses. There's data demasking. This just ensures that if you send something like a name or phone number, instead of that actually being sent to the large language provider, a placeholder is sent instead. And then when we get the response back, we dynamically take the placeholder and put the original data back in. And then finally, there's an audit trail that you have access to inside of Data Cloud. And once all of that is done, the response is actually surfaced. Cool. So that is the end of my presentation. And I'm going to just take a quick look to see where everyone is joining from. So we have a lot of cool people. We got people from Seattle. I'm actually from Seattle. I see Ayondizi from the Netherlands. We have Lucille from New York. Special shout out to you. And we also have Naket. Hello, Naket, calling in from Pune, India. Awesome. So let's get started, because this is not slide live, this is code live. So let's do some coding, let's do some building. So one of the best ways to actually explore an API, of course, is via Postman. So let's hop into Postman and do some exploration. So if you use, and we have Amin from Montreal. Hello, Amin. All right, so what you see here is Postman. If you are not familiar with Postman, you should really check it out. It's an API client that makes it easy to test out and explore different APIs. Salesforce actually maintains an official Postman collection library to make it easy to explore our different APIs. Now, what I have done is just to fork one of the APIs that we already have, API collections that we already have for the Models API, so that you can test it. So I've forked it here, and what we're going to do is just explore it. So the Models API comes with 4 different endpoints. There is an endpoint for generating a one-off prompt using REST or Apex. So here is essentially how it works. You are going to use your base URL for your Salesforce org. And then you'll pass in the model name, because the Models API actually supports an extended list of models from OpenAI and Azure and Anthropic, which are 3 big large language model providers. And using this endpoint, you can then create generations and programmatically create responses to prompts. So what we have here is just a prompt that asks, what is REST API? And for this particular response, I am going to be using a model, let's see, a model name. I have a placeholder here. I believe this is ChatGPT 3. So I'm using GPT 3.5 Turbo. So let's take a look at how this works. So I'm going to quickly send my response here. So one thing you're going to need to do, and this is true of the Postman API in general, when you're using making APIs with Postman, you need to ensure that you have a token to make these API calls. So it looks like my token has expired, which is why I have an invalid token. So what I'm going to do here, and we have this set up in all of our different Postman collections. I'm going to go to authorization, and I am just going to quickly get a new access token. I'm going to use my token. Okay. And let's just take a look at our response once more. We have a valid token. So what we're going to do is just give it a shot. And what this does is create a one-off response. And you can do this over REST and Apex. And of course, we're just doing it over REST. And this is what you get back. So when you make a request to the Models API, you send in your prompt. It's just going to be a JSON body. So we sent, what is a REST API? And here's our response from the Models API. See if we can make this a little bit bigger so you can see it. And we have our generated text. So this is the response from the model. REST is a type of web service that allows communication between standard HTTP methods like get, post, put, delete. Sounds right to me, right? But in addition to the generated text, you also have some of the data that comes from that Einstein trust layer that I discussed before. So in this case, we also have scan toxicity to determine whether or not anything in this actual response is toxic. Now, when it comes, so here you can see if there are any toxicity detected along a variety of different dimensions, whether it's identity, hate, profanity, violence, anything like that, um, and just a variety of different information. You also have an idea of like how much was sent. So one thing to know about large language model providers and large language models in general is when you send them, you're using a resource called tokens. And tokens just represent how much text you sent and then how much text was generated. So here we can see that our prompt was 13 tokens, and a token is about 4 characters. It's a 4-letter word, like 4. And then the total tokens, and then the completion tokens are the tokens that you got back. So this is pretty much the length of the response we got back. So it's about 100 tokens or 400 characters. So this is the generations API, and you can use this for a variety of different kind of one-off scenarios. It's very useful. So the next API, and the one that I tend to be the most excited about, is the Generate Chat API. Now, this is an API that allows you to build a chatbot with a variety of different models. If you've ever used ChatGPT or Claude or Gemini or anything like that, where you are doing back and forth prompts and responses, and the models keep in context of what you're saying, this is what the Generate Chat API allows you to do. Now with this, it works very, very similar to the previous API. So you are going to pass in a model name. And again, there are a variety of different models that you can use. As a matter of fact, I'm going to show you what those models look like in just a bit. And you're going to pass in a body. Now, when it comes to sending messages to the chat generations API, it's a little bit more complex because you're having a conversation. And as such, you need a way to be able to send the entirety of the conversation and what you're asking to the model. So if we take a look at our response here, if we take a look at our API call here, we can see that in our JSON body, we have a messages key. And in our messages, it's a list of messages. Now, within the messages, there are broadly 2 types of messages. There's a message from a user. So that represents the person that is asking the questions. So in our case, we have a message from a user that's asking, can I use the Salesforce REST API to retrieve a record? And then there's also the message of the role assistant. And this is what came from the API when you ask the question. It's important to have this so in your list of messages so that the assistant remembers what it said to you prior. This is how you keep context of the conversation. So in this case, we are sending to our assistant that we asked them a question, they answered it, and now we're asking the assistant to show an example of how to use the REST API to get back the contact object in Salesforce. And that's essentially how you do it. It's a little bit more complex than a one-off generation, but a one-off prompt, but it's still pretty straightforward. So let's give this a shot as well. So we're going to quickly make an API call, and we can see our response. So here, again, we're going to get our generation or what the large language model came up with. And as you can see here, we have a new generation here. We have a new response from the assistant. So we can see the role is the assistant, and it's always going to be the assistant when you make a request and you get a response. And then the content of their actual message is right here. So it's saying sure, and we have a example of how to retrieve a contact record. So it did exactly what we wanted it to do. And in order to build a chatbot with this, what we would essentially do is grab this content and then add it to the list and then make another request. And that's how you essentially build a chat. And we'll see that with our actual chat app pretty soon. Next, we have generate embeddings. So embeddings is probably one of the more, it's not complex, but it's a little bit different from a lot of the other APIs that you'll see with large language model providers. So an embedding is a numerical representation of what a sentence means or what a chunk of text means. Why is that helpful? Well, it allows you to determine whether two sentences, two chunks of text are related to each other or not related to each other. And you can use this to kind of build your own like search engine if you wanted to, or you can use this to give yourself the ability to inject related context into a prompt when you are submitting a prompt to a model. This process of like using an embedding or just generally retrieving information and then injecting it in a prompt before you send it to a model is called retrieval augmented generation. It's its own topic, and we won't go too much into it here, but I just want to show you that when you use embeddings, it takes these words and then translates them into numbers that you can then compare. So here I have two inputs, two chunks of text. One asks who won the NBA championship in 2004, and the other has an answer to that question. So when I send this to the embeddings model, I am going to get back a list of different embeddings, and this is just a chunk of numbers, right? But if you do some math with these numbers, you can see how related the text actually is. So here it would be pretty hard to do the math by hand, but I actually wrote a quick program inside of Postman that logs the difference and does the math for us. So I'm going to pull up my console here, and if we take a look here, you can see a message that I created here, and it just says the semantic similarity of these two messages is about 65%. So it would generally be between 0% and 100%, with 100% meaning they are literally the exact same, they mean the exact same thing. And to prove that that is true, I'm going to just go ahead and take this right here, this line right here, and let's replace it. Let's see here. And if I send this again, and I look at my console log, the semantic similarity between these two strings when they're exact same is 100%. So that's what embeddings do. They allow you to compare text to each other to see if they're related. And then finally, we have an API that allows you to just submit feedback for any of the generations, any of the chat generations that you make. And this one's really straightforward. You're going to create an ID for the individual feedback item, and then you're going to add in the ID of the chat generation, right? So all of the API calls I made had an ID field. You would take that ID and pass it into the generation. You'd also pass in the feedback category, whether it's good or bad, as well as any feedback text. This is useful just to ensure that like users are actually finding the information that you're submitting and they're getting from the large language models provider that it's actually useful, right? So here, when you submit feedback, Salesforce just lets you know that the feedback was received, and that's it. So I'm going to check to see if we have any questions. And if you do have any questions about the Models API, definitely ask them in the chat. So that's the Models API at a high level. Next, I would like to show you just like a quick demo of how you can actually use this. So let's hop into some code. Let's take a look at something here. Okay, so what I have here is a Salesforce org that I created using the Einstein AI Playground. So if you are working on Salesforce applications and you have been trying to get access to like a sandbox org, or like not a sandbox org, an Einstein Playground that actually has access to the Models API, Prompt Builder, Copilot, it's really important to note that there is actually a trailhead module called Get Started with Prompt Builder. Let me just take a look here. Started with prompts with Prompt Builder. Let's see here. Get started with prompt builder. I actually have a repo here that has it. Let me take a look here. Yeah, so that's uh, get started with prompt builder that allows you to create a short-lived org that has access to this API and all of the other cool generative AI stuff. If you're interested in trying the stuff on hands-on, I highly recommend that you build an org in Trailhead and try it out. Another thing that I want to note is that everything that I'm going to show you and a lot of the resources I'm going to be talking about, including the demo that I built, is in a repository that I have made public on GitHub. And in fact, you can actually, let me give you the link here, just a moment. Let's see. We have the link somewhere. Here we go. And I'm just going to add this here. So if you would like to actually test out this demo that I built, if you'd like to see some of the resources that I refer to, check out this GitHub repo. I have a short link that takes you right to it. It's just sforce.co, codeLive models API. So give that a shot. So let's actually take a look at the demo here. So here I have a generative AI chatbot that is built and powered by the models API. So this is how it works. It's a single Lightning Web component inside of the utility bar inside of the Sales app. You can embed this in any app that has a utility bar. And the way it works is you have access to a variety of different models and model providers. So here we're using OpenAI as well as Anthropic, and we are able to essentially have chats in the same way that we would have chats with consumer applications. So let's submit a really basic chat. Write a poem. Let's see. Actually, chat, does anyone have an idea of, anyone have suggestions of what we can prompt this Gen A chatbot to do, since that's one of the most, one of the great things about chatbots is that they are so flexible and they can do so many different things. But I'll just prompt it to write a poem, just a generic poem, just to see what's on its mind. Now we're using OpenAI GPT-4o, which is a relatively fast model, but it does take a little bit of time. And unlike some of the consumer applications, at the moment, the models API doesn't have what's called a streaming API. Oftentimes when you interact with large language models, they have a streaming API where they send you text one piece at a time. In my case, I get the entire text and then I kind of render it out slowly so that you have a kind of a same feel of it typing it out. But as we can see here, we have a poem. And to show that the model is not just doing a one-off generation and that it's keeping context, we can ask it to summarize the poem. And one of the benefits of this, again, is that because this uses the Einstein trust layer, you don't have to worry about the text that you've actually been, that you're actually sending, or the responses that you're getting being used to train the next version of a frontier model. The Einstein trust layer ensures that because it's going through the zero retention gateway, nothing that you're sending and nothing that you're getting back is being retained. This is really important because that's the primary reason why you generally are told that you can't use consumer grade applications that use generative AI. But in the case of Salesforce, you can. And in fact, because I work at Salesforce and I'm under the same kind of like restrictions, This is the consumer AI that I tend to use. This is a tool that I built inside of Salesforce, and I use it all the time to help me do my job. And it's pretty useful. So as you can see here, again, it has context of the previous input of what I asked it, of what it said, and it's able to then give it a critique. And just being able to maintain that context allows us to build a really powerful AI bot where we can where we not only have access to OpenAI models, but we have access to Anthropic models and hopefully access to a variety of different models from a variety of different partners in the future. Now, one thing you might be wondering, however, is how does this work? How are you able to actually integrate the Models API inside of a Lightning Web component using Apex? So let's take a look at that as well. So we're going to hop into Visual Studio Code and take a look at how the Apex side of this works and what it looks like in the context of a Lightning Web component. Now, if you've ever built a Lightning Web component, you've ever used Apex to power a Lightning Web component, this will seem pretty very familiar. Okay, so we're gonna hop into our code here. And this is all the same code that I have for the repository. So let's just start off by understanding how the Models API works in the context of Apex. And actually, let's take a look here. Let's just take a look at the chat, see if we have more folks joining. I see we have some folks joining from Cleveland. Love Cleveland. We have some folks coming from joining from Italy. Hello, hello, and welcome to the live stream. And of course, if you have any questions about the Models API, if you want to see the code and the resources, it's right at the bottom of the stream. So let's just take a look at how the Models API works in the context of Apex. So it is, or it might look a little bit more involved because we're writing code as opposed to using Postman. Postman does a lot for you. But here's the general pattern. So you are going to first initialize a Models API object here using the Models API. And you're also going to create a request. Those are really the two kind of interfaces you're going to be using when you're doing anything with the Models API as it relates to like one-off prompts or chat generations, right? You're going to initialize the API and you're going to create a request because you're making a request to the API. So the first thing you'll want to do is just specify the model name. Now, there are a variety of models that you can actually use inside of that you can use with the Models API. And we can take a look at that here. Let's actually hop into the docs to take a look at that actually. So if you go to the Models API docs, you can see that there is a list of different supported models, geo-aware models, Salesforce managed models. You can also bring your own model. That's something to probably explore in another live stream, but it's really, really cool. And you can see all of the different models that you can actually use. So here we have our geo-aware models. We have our ADA model for embeddings, GPT 3.5 Turbo. We have Turbo with a larger context window, so 16K. We have the instruct model for the cases where you want GPT to just follow instructions. That model is fine-tuned for that scenario, as well as GPT-4 for Omni, GPT-4 Turbo. There's also some Salesforce managed models. I believe there's, let's see here. There's also, here we go. We have Anthropic 3 Haiku. That's one of the really useful, pretty fast models from Anthropic as well. So you can check out all the different supported models we have here. But in our case, if we hop back to our code, we're just going to be using AI default GPT 3.5 Turbo. The next thing you're going to want to do is just send the context of the messages that have been sent. So in our case, we're going to create a map that has the role, a system role. This is just a system prompt. So if you want if you want the LLM to follow some specific instructions about the chat itself, right? Give it some context of what it's doing. You can submit a system prompt. This is optional. You don't have to. But in our case, we're going to just say it's a helpful, smart, and kind AI. And then you have the message from the user. So you'll take this message, you'll add it to a list of messages, and then you'll essentially create a chat message request. These are all of the different messages inside, all of the different messages that you want to put inside of the request. You'll add the list of chat message requests to the request body, and then you'll just submit it to the models API by adding the request to this create chat generations call here. And what you'll get back is a response with a response code, some details, the generation itself, and then the content. This aligns with what you saw inside of Postman. You just need to, it's just because, when we looked at it at Postman, it was JSON object. We need to kind of go through it and get to the content that we want. And then here you can just get your response, right? So if we execute this in Anonymous Apex, we can see how this works. And I'm going to go take a look at some questions. Okay. So question here, let's take a look at this question here. Are there any limitations that ISVs that want to leverage these APIs and managed packages should take into consideration? Is a good question. So there are a few different considerations. First, you're of course going to have to consider and ensure that the folks that are using this API have access to Einstein generative AI. First and foremost, you're going to want to essentially ensure that your managed packages. You know what? That's a really good question. You know what? I'm kind of curious. Like when you ask that question, did you have any limitations in mind that you were curious about? Because it's an API like any other in the context of Salesforce. The main difference is that it just brings some third-party capabilities to Salesforce that we didn't have prior. Okay, and I see your question here. I'm just trying to take a look. Here's the question. So the question is about tokens. And I think one of the questions in general is about Einstein credit consumption. Okay, so that is something that you'll want to consider. There are definitely specific limits as it relates to using Einstein generative AI. And there are absolutely limitations around how to use it. In the context of like the demo, when you're using a generative demo org, it's important to know you only have like 200 requests per hour. As it relates to actual orgs, it's going to depend. Now, there is some really good documentation on how to get to Einstein usage limits, as well as a rate card that gives you more details and with regard to how many Einstein requests you can make. There's also the consideration that when you are making requests, and when you're making requests, you're taking advantage of the Einstein trust layer and all of that different architecture. And so if you bring your own, if you use Salesforce enabled foundational models, the multiplier of the request, the calculation of like how much you're consuming is a bit higher than if you bring your own model. So if you want to bring your own model, you have a fine-tuned model, and you bring it and you leverage it for the models API, the Einstein requests that you use are a little bit less. In terms of the actual calculation, I don't know that offhand. I'll add it to when I believe it's actually in this rate card or the doc before the rate card, but I don't know it off the top of my head. But there are absolutely limits with regards to Einstein generative AI usage. It's a really good question, and it might be worth its own live stream. Cool. So I believe we got back our response from our Apex call. Let's see here. So here we go. We sent to the model, just again, write a short poem, and that's exactly what we got. Well, not too short. And so in the context of LWC, right, you would of course want to build your own class. And it looks like we have someone on my team that's going to help answer that specific question. All right, so in the context of LWC, you need to build a class that takes advantage of this API. So what you can do is essentially wrap what we had here in an Apex class. So here you would want to make an Apex class. You'd want it to be Aura enabled. And what you do is create a method to create a chat generation. Now in my case, I want to be able to take in an input as well as a model name. And so that's what it does here. And we want to output a essentially just like an object that contains our messages list and the response. Okay. So what we have here is pretty much what we had before: instantiating the class, creating the body. We have just like a conditional here where we're checking to see which model we're using because we want to add in a system prompt. There are certain models that don't support system prompts, one of them being Claude 3 Haiku. We're listing through the messages that we're getting, and then we're adding them to the request body. And then we're just creating a chat generation using the model's API as we did before. So it's all the same code essentially. And we just return our response. Now in this case, we're going to return either a response that contains a generation, which contains like the actual response, or like an error. And that's what we need to do there. Now in the context of the actual Lightning Web component, actually, I'm going to check questions here. Okay. And we also have some folks from the actual Models API team here to ask questions, to help answer questions as well. So if you have some questions that I cannot answer, you should absolutely continue to ask questions, because that's an incredible resource to have the folks who are building this in the chat as well. So essentially, if you want to build a Models API chat generation, you'll take the code, you'll take the general pattern that I showed you before, get in a model, creating a response, adding into the response the list of messages, and then making a response and calling create chat generations with that request. You'll wrap that into a Models API wrapper so that you can then use it inside of your Lightning Web component. Now, in my case, I have a Lightning Web component called Chat Utility, and this is the entirety of the app that you just saw. Now, in order to actually get our generation, there are a few different things we're going to do. First, we're going to track our selected model. So there's a variety of different models you can use. We just want to know which one you selected and keep state of that. There's the chat log, which is everything we've sent and gotten back from the model. So we'll be keeping state or tracking that. There's the user's input, which we will add to the chat log prior to sending it to our Apex service. And then we have just like a nice little is loading state to show whether or not the request is kind of being processed. Okay. Now, in terms of how this works, I have a single handle message handler, and this is what we will essentially invoke whenever someone clicks send or hits enter inside of the text area where they want to ask a question. What we're going to do is just take the input. We're going to add it to. We're going to create an object that contains an ID, the message, the text that was in the input, the role, since it's a user. We are going to set the state of the app's is loading state to be true so that we can have that loading animation. We're going to add the object that we just created that contains the message that the user wants to send to the chat log. And then we're just going to map through our chat messages so that we're sending just the role and the message to our API. And then finally, what we'll do is call our create chat generation service from Apex. And this is something that we've imported from Apex into our Lightning Web Component. And again, it's going to take in two things, the same two things that we defined in our Apex class, an input and a model name. The input is going to be the chat messages, which comes from just this line here. And then the model name is just going to be our selected model state. So when we get our response, we're going to check to see whether we got a generation object, which would contain a generation or an error. Okay. And if we get a generation, it'll have some type of text that the model responded with, and we can then have that simulated typing effect that you saw before. And then finally, we will just set the user's text area state to be empty, an empty string. And that's really all it takes to build a chatbot. Of course, there's a variety of other handlers that I have here in this Lightning Web Component, but that's just to make it look a little bit better or add functionality or just handle different input change, things like that. So let's take a look again at our application here. And again, just to give you the rundown, we have another button to clear the chat. We have a list of different models that we support. We can use Haiku if we want. We have our input area, our text area where we can send messages and add it to our chat list. And then when we hit send, the only thing we're going to do is we're going to be invoking that create chat generations requests. And we're going to send it to our model and get back our response. Some ways to use Salesforce Lightning Web Components. And of course, we can ask all different types of questions. We can use these models to help us write. We can use it for brainstorming. We can use it for summarizing things. We can use it for really any scenario where you want to keep state and you want to have a multi-turn conversation inside of a Salesforce application or even outside of a Salesforce application. It's really powerful stuff. It's, as you've seen, really easy to integrate. It supports a variety of different models, and the amount of models that it supports will continue to increase. It includes a feedback framework. It's natively supported in Salesforce and REST, and it's something that you could use knowing that your responses and your generations are not being stored or used for any future frontier models or any training sets. So I'm going to take another look at the questions here. Okay, so here's another question. So does Salesforce have on their roadmap a plan to offer a vector database to Einstein-enabled orgs? So currently, Salesforce does have a data cloud. And on the roadmap, I believe in beta, is support for a vector database. As a matter of fact, that is one of the use cases of Data Cloud. So if you're interested in vector database use cases, being able to do retrieval augmented generation with Einstein AI, which is something that's really, really powerful, look to Data Cloud for those capabilities. It's a really great question because vector databases take advantage of embeddings to allow you to be able to quickly retrieve context that might be relevant to a prompt, for example. So that's a really, really great question. Finally, I want to remind you all that if you are curious about the Models API, if you're interested in trying this out, I have shared all of the code here in this GitHub repository. It is public. You can see it using the link that you see below. And you can also see links to the documentation as well as how you can get access to an Einstein playground org via Trailhead. So, and that is it. And that is it for today's codeLive and Code demo. I highly recommend that you check out the Models API. It is an incredibly powerful tool that can allow you to build generative AI apps, use embeddings. It has a feedback framework that is connected to Data Cloud to allow your users to be able to provide you with feedback to let you know how useful your generative AI tools and your generative AI responses happen to be. So thank you all for your time and attention for joining me here at codeLive. Have a great rest of your day wherever you are. Take care.